All right, hi guys. I'm gonna walk you through a couple of problems here as a quick take, and have you do some practice problems with the substitute today. So basically, this is a subtraction problem, right? I can see right here that it's subtraction. The way I like to do subtraction problems is, the same way I was taught to do them. I put the minus sign here. I put the first number up on top. But I'm going to order these. Like, this is not the order that I want them in. I'm going to put this term that has the fourth power, that's negative 3n to the fourth. I'm going to put that first, negative 3n to the fourth. And I'm looking for anything to the third, and I don't see anything to the third. In fact, there's nothing over here to the third either, right? But I do have this term for the second, right? So that's positive 10n squared. And then I have this 8n, that would be to the first power. They don't write to the first, but there is a first there. So 8n. And I think we talked about this yesterday, but the idea of making columns and keeping your columns true, right? So anything that I'm going to take away that's from the fourth, like this guy right here, right? It needs to go in the column with the fourths. So 11n to the fourths, right? And then here's a square right here. That's 3n squared. There's no sign in front of this one, so I assume it's positive. I'm subtracting. The subtraction sign's out here, right? So once I put subtracting, I know I'm going to be subtracting all the way down. And the only other thing I'm going to take away is negative 7. And that's going to be taken away from 0 because there is no number over here that is just a straight up number. And I'm not subtracting any straight n's here, so 0n, I'll just write that. So now it's pretty easy. I know it might not look easy, but I'm going to look here and say, well, I know I'm doing n's to the fourth, right? So if I have negative 3 and I take away 11, I think if I owe $3 and then I take away 11 more, I'm going to owe $14, right? If I have $10, but I take away 3, I'm going to end up with $7. That's positive, right? And these are my n squares. If I have $8, just easy for me to think, and I take away none, I'm still going to have my $8. Or the n's are not dollars, but you get the idea. And now if I have 0 and I take away a negative, now taking away a negative is the same thing as adding a positive. So if I'm at 0 and I take away negative 7, I will add 7. So there's my answer right there. And this is called standard form, and it's where you would take and put the highest power will be up first, right? So in this case, it's the fourth power, and then it goes down, and these powers go down like that. So that's standard form. Okay, let's look. We got a couple more little problems here to do. This one doesn't say what it is, but I know that this implies multiplication. And so I would just think if this was 73 and this was 127, I would line them up to multiply. So that's what I'm going to do. I'm going to just say 7k minus 3, and I'm going to multiply them times k squared minus 2k plus 7. And I'm going to start with this green right here. I'm going to start with this number, just the way I multiplied before. Negative 3 times 7 is negative 21. Negative 3 times negative 2 is positive 6, and then there's 1k there. And negative 3 times k squared. Now, there's a 1 in front of here. It doesn't see it, but negative 3 times 1, makes this -3, and then I have the k squared. So that's what I got from multiplying the -3 times each of these terms up here, right? Let's switch to another color here. And now I'm going to multiply the 7k. And it's got to be multiplied against each of those 3 terms. But the key here is for me to make sure I put the result of the multiplication in the right place. So this is 7k times 7. So the k is going to stay the same. So it's going to go in this column with this k. And the 7 times 7, I know that is 49. So 7k times 7 is 49k. And here I have 7k times -2k. And the k times the k is going to raise it a power, right? It's going to raise it a power. So that's going to be k squared. And the 7 times -2 is -14k squared. And then I got to do the last one, which is 7k times k squared. And that's think of it as a 1, right? 7 times 1 is 7. But then I have k times k squared. It's going to raise it a power. I'm going to have k cubed. So now I need to add all this together, right? So -21 plus 0 is -21. 6 plus 49 is 55k. -3k squared plus -14. Well, this is -3 and I'm getting more negative. -3 plus -14 is -17k squared. And this would be 7k cubed. So my answer is right here, right? Now, the key is to recognize that I multiplied, right here, this 3 times each one of these 3, and I put the result right here. And then I multiplied this 7 right here times each of these 3 here, and then I put the result down here. And as I'm multiplying, I'm making sure that I count the number of k's to get them in the right spot, so that when I add, everything is in the right column for me to add easily. Okay, I got one more problem set for you. Here we go. We're going to take a look at this. Let me get it actually an example of the problem set here. Sorry. And this is called simplifying rational expressions. So I'm gonna start with an easier kind of looking one right here and go to a harder one, right? Here's an easier one. So I've got to think about what this is, right? So this is what we call a rational expression. And it gets the name rational because it is a ratio, which means fraction, right? So what do I have? I have the number 15n. So what happens with rational expressions is what's on the top is all being divided by what's on the bottom, right? So this would be 15n, and it's being divided by 30n cubed. Now here's where it gets kind of interesting. If I have something that is being multiplied on the top and divided on the bottom, and it's the same thing, it can cancel out. So for example, here I have 15 times 1, that's 15, times n, that's what's on the top here. Then on the bottom, I recognize that 30 is actually 15 times 2, and then n cubed is times n times n times n. So I'm looking, are there any things here that are being multiplied top and bottom? Because if I'm multiplying on the top, right, then I'm multiplying it here, but I'm dividing it here, and those operations cancel out. So the 15 and the 15 are going to cancel out, and this n and this n are going to cancel out. So what I end up with is what's left here, 1 over 2, and then n, this is n squared, n to the second power. So my answer is 1 over 2n squared. So sometimes it's best to try to break this down. Now, it helped that I knew this was 15 times 1 and this was 15 times 2, right? They get harder. Sometimes you look at them and they get a lot harder. So I'm gonna get some of these harder ones down here. Holy cow, I'm gonna look at this right here. These are some hard ones. So let's see if I can try on something like this problem right here. Let's just see what I can do. All right, in fact, these might be beyond your ability yet because we have not practiced factoring, and factoring is going to be needed here. So we'll talk about what factoring means. When we have a plus sign up here, right? So here I have a plus sign. Everything isn't being multiplied, and if everything's not being multiplied, you just can't cancel the top and the bottom. So what we can do is we can look for common things on top and bottom. So I know this is 9x times x plus 81 times x, right? That's what's on the top. So forgetting the bottom, I'll do the bottom over here in blue in a second, okay? But let me just stick with this top here. So what I notice is that this 9 times x and 81 is 9 times x. Oops, sorry, let me fix that. That isn't right. What am I saying? My eraser go. Here we go. That's not my eraser. That's not my eraser. Where's my pencil? Sorry. All right, let me grab it this way. The button's not working here on my pen. 9 times x. So I see this 81 is 9 times 9. Now, this is all inside. This is all one big group of sets of numbers. And what I'm going to do is I'm going to recognize I have a 9x here in the first part and a 9x here in the second part. And so what I can do is this is like factoring. I'm finding a common factor. I have two terms here, right? I have this term here, that's number 1, and this term here is number 2. But they have a common factor, which is 9x. So I'm going to put the 9x on the outside of a parentheses. And then on the inside, I'm going to put this stuff, x plus 9. So I'm just rewritten this top to be 9x times x plus 9. Let me erase some of that stuff here. Okay, 9x times x plus 9. I think I want to do that because I'm pretty sure maybe there's something I can do. I don't know. We'll see. So now what I have here is I have this blue thing, right? X cubed. So I'm going to look at what this is. This is x times x times x times, oh, that's x cubed. And then we have plus, that's my first term. My second term is 8 times x times x. And then my third term is minus 9 times x. Man, I just feel like there should be some way. I know I can get an x out of here, right? I can get an x out of here. Now, why am I doing this? Well, because see this x here, this is now multiplication between two parts. Let me show you this, right? Let's make sure you see this clearly. This is now being multiplied by that. So, and this is multiplied between the two of them. So I have three things. That 9 is times x is times this little circle here, right? So if I can get stuff out by distribution, pull it out, then what's left, I can maybe possibly cancel. So see this x here, there's an x here, and there's an x here, and there's an x here, right? So I'm going to pull those x's out. I'm going to put x on the outside. In the inside, I have x times x plus 8x minus 9. And I'm going to actually rewrite this x times x. I'm just going to, do it the right way mathematically. That's x squared. All right. So what that tells me is if I want to, I can put the x times x squared. Oops. Yikes. Now let's see if my eraser will work again. I don't know if this is going to work. We'll try it. We'll just see. No, not working as an eraser. There it is. All right. X squared plus 8x minus 9, right? So this x here, right? This x here and this x here, they can cancel out. So then I've got 9 times x plus 9. Trying to make this look a little simpler. And on the bottom, I just have this thing, right? Which is x squared plus 8x minus 9. Let's see if I can move this with my mouse. So I'm just looking at this problem and I'm thinking, can I factor this further? Okay. So sometimes what's really helpful for me is to make a rectangle. And I think about, is there a way for me to find factors that come up with x squared and factors that come up with negative 9? And is there a way for me to do that? Well, if I think about this as an area, right? So this is a two-dimensional measure, right? So if the one-dimensional side length was x, and this dimensional side length was also x, it would give me an x squared. So now the question is, how can I get negative 9? What would these dimensions, like this dimension here, have to be, and this dimension here have to be to get negative 9? So one way to do it would be like to say, okay, if this measures negative 9, and this measured, or let's say this is positive 9 units long, let's say this measured negative 1. Then negative 1, this direction, times 9, this direction, would give me an area of negative 9, right? And then what would these areas be? Well, remember this here, I'm going to go back to this color. This is blue. This blue thing measured x. So this would also be x. So we would have x times 9, right? So this would be 9x. And this thing over here was also x. So this was an x squared. So this is x, right? Times negative 1. So this would be negative 1x. So now I could look at what would this whole area be, right? Well, part of it is the square in the front, x squared. Part of it is the square down here in the back, or this rectangle down here in the back, negative 9. And then I have these two parts right here that can be combined. What is 9x minus 1x? That is 8x. Now, if you look, that was the expression that I had here. And what it tells me is that I can break it into these factors. So doing this little area model for me, because I knew this was an x squared, so I knew we could get into two-dimensional analysis of these numbers, right? I can think of this as the area x squared plus 8x minus 9. That's all this area. And what are the dimensions, right? So what's the length and the width of that area? Well, one side is x minus 1, and another side is x plus 9. All right, so these two things, this right here, let me get this thing in blue right here, which is the area, is equivalent. It's the same thing as this dimensions, right? This would be the length, right? And this would be the width, or vice versa. It doesn't really matter. But if you multiplied this length times this width, you would get that area. So that's what we call factoring, right? So in other words, this whole fraction that I have here, right, this whole entire fraction, I'm going to rewrite it over here, right? What I'm going to do, pick purple now, let's see. I'm going to say on top is 9 times x plus 9. And on bottom is x minus 1, the length, times x plus 9, the width. And this is times and this is times. So guess what I get to do? See why we want to do that? Because guess what? X plus 9 and x plus 9 is going to cancel. So that leaves all that work leaves so that I only have 9 on the top and x minus 1 on the bottom. Now I want you to look here real quick. This fraction right here is exactly the same fraction that we started up with right here. Let me write it again. 9 over x minus 1. That is the equal fraction of this. Believe it or not. This is just simplified. Whew, because it is a lot simpler to look at than all of this garbage that's here. Man, is it a lot simpler to look at than all of that garbage here. Okay? And the way we got it out, let's go back through it again. Number one, let's move this. Sorry. Number one, we started with the top. We rewrote it as 9x squared as 9 times x, and 81x as 9 times 9 times x. And then we saw the 9x on here and the 9x over here, and we wrote it off to the side. The bottom, we recognize each of these terms has an x in it, x, x, and x. So we were able to pull one x out and rewrite it as x times this, what we call this trinomial. And this trinomial looks a lot like that trinomial, just has one less x in it. And that x, and x from the top up here, right, and the x from the bottom right here got canceled out. So we ended up simplifying a simpler trinomial, and this factors up top. Then we could start working on factoring this, what we call a trinomial. We call it trinomial, nom meaning like nombre, names. There are 3 terms here, trinomial, 1, 2, and 3. Thinking of this, seeing the square and saying, hey, this is an area, right? It's a square measure, so it has an area. What would be the dimensions, right? So I know making x squared, making -9. What are the numbers that make -9? And these are like little puzzles. What two numbers multiply to -9 but add to +8? See, you can't always find them, but if you can find the two numbers that multiply to -9 but add to +8, then you can factor it. And that's what we did, x minus 1, x plus 9. And once we had the x plus 9 on top and bottom, we rewrote the whole thing. Okay, see if you guys can work on some of those. I know those are hard, but see how many of them you can do.